Hello, this is Jackson, and you are welcome to the Qtum video blog. This time we will install the Qtum Core wallet as a superstaker in the cloud using Amazon's AWS service. This will be the Qtum daemon wallet installed using the Qtum Amazon Machine Image template, then configure and operate it as a superstaker for offline staking. Here are the main steps. We will launch a virtual private server and instance on AWS to run the staker. We will use the WinSCP Secure Copy Protocol app to back up our cloud wallet on a USB drive and set up and operate the superstaker. This drawing shows how you access a cloud data center running the VPS. This architecture is widely used for business and commercial applications, since the cloud has many advantages compared to on-premise systems. These are very reliable, very secure platforms, basically ideal for running a superstaker. You don't know or care where the data center is and its physical computers are located, but if you want to see what one looks like, the link above shows a data center in North Carolina, USA. Now let's get started. The first thing we'll do is get WinSCP to do the backup of our wallet from the AWS instance to our Windows desktop, actually a USB drive, and we'll do that later. We'll connect up to the WinSCP site, download and install the software. Using WinSCP is a little bit complicated. There are a number of steps, but less steps than setting up other approaches with FTP servers or using an FTP server from Amazon. After we install WinSCP here, we'll come back to it a little bit later in the video after we've set up our wallet and actually do the backup. So stand by for that. Now we're going to get an AWS account. You can go to this URL and create an AWS account. Fill in your email. Let me make one up here. Yes, that's a good one. And enter your password. This is the usual thing. And we'll give it a descriptive name like my AWS account. There are several more pages of form to fill out, including all your details, phone number, credit card, etc. But to save time, we're going to skip over that. Now we'll launch an instance of Qtum. To back up the private key files used for logging into AWS, we're going to first create a folder on the desktop called AWS, where we're going to park those files in a little bit. Now you want to sign into your AWS account. You can use this URL. By the way, all these commands will be given in the text version of this blog, where you can just copy and paste them into text files that you can use yourself if you want to follow along. More information about that in the references. Now we'll pick a region for our server. We'll choose London, and we'll use a T2 small instance, which has a particular set of resources that are shown there. We could also use a T2 micro, which has less memory. In that case, you need to set up a Linux swap file, and the references have a link that shows how to do that. Click Continue to subscribe. And then we'll click Continue to configure to set up and configure our instance. Again, we'll set the region to London and click Continue to launch. Now we'll do some more setup steps, the security configuration. So scroll down to security group settings. We'll choose these based on what Qtum has recommended. We'll give it a descriptive name. In this case, we'll call it Qtum AMI. And then give it a description. This is generic information. Of course, you could write whatever you want in there. Now here's the connection methods shown right below there. We've got SSH connections on port 22, and the node itself will use TCP port 3888. We'll change that in a little bit because we're working on testnet today. Click Save. Now we can create that private key file that will be used to securely log in. We'll create a key pair for EC2. Again, we'll make sure it's set for Europe, our region in London. And we'll click Create Key Pair. And here give it a descriptive name. I like to say the region and the date in case I want to make some instances later in other regions at other times. You need to keep track of these key files to sign on to each instance. And we'll set it for a PEM file. We'll come back to this topic of types of key files in a little bit. And we'll create the key pair. This is going to download that private key file to your local computer, and this is where we're going to just copy it into that AWS folder so we know where it is. Now we want to go back to the AWS Marketplace tab. Which is right there. And after we refresh our key pair settings right here, now it knows the private key file we want to use, and we're ready to launch our instance. By clicking on Launch. Now at this point you have an instance running on AWS in their London data center with Qtum installed. So let's take a look at that. We'll go to click on the link for the EC2 console here. This will show your instance, more if you have them. We want to do a little more configuration. Oh, it's a good idea to bookmark this page so you can come back to it later. So on the left side of the page here, we're going to scroll down to Network and Security, Security Groups, and we'll select our instance that's running and select to edit the security rules. This is where I want to change the incoming port permissions to port 13888 because we're on testnet today, or you could leave it set on 3888 for mainnet, and we'll just make a note here that this is for testnet. At the very end of the video I'll show you how this helps us out with incoming connections. Now we'll scroll back up to EC2 dashboard, and we'll select instances running. We're navigating back to our instance that's running. There it is. And if we click on the instance ID, which is this long long number here, we can get more details on the instance and see what's going on, and more important, connect up to it. So we'll click on Connect. This is going to give us a template of how to connect up to it from our local machine terminal. So go down under step 4 here for the example. It's got it all written out for you. Copy that. And I'm going to paste it into the text file here so I can find it again later when I want to log in later. I need to make some adjustments though, so I'm going to copy the template again and edit onto that copy. So first I need to give it the full path on Windows, which is going to be in the C username desktop AWS. That's that desktop folder that we created. So I pasted that in there. Now Windows knows where to find that file. The other thing I need to do is change the name of the user. We don't want to log into root, we want to log into Ubuntu, which is the name of the user in my instance. That's where the wallet is installed. So that's our edited sign-on path. I'll just save that in the text file. And now I can copy and paste that into a PowerShell session. I like to use Microsoft PowerShell because it gives me a little more flexibility in editing in the terminal session. So there it is. Let me expand the font a little bit here so you can see it better. So we're going to copy this edited sign-on command and paste it into the terminal. It will be able to go look up that password file or private key file to log in when I hit enter. And there we are logged in. So now our PowerShell terminal is SSH'd into the instance running at Amazon. And let's go ahead and update all the versions of the software. This is something you should do whenever you do a new install, and then periodically when you come back to it, because there will be updates to Ubuntu, there'll be updates to Qtum, and so if we run that, it'll do all those updates. And for example, coming up in a little bit here, you can see it will even update Qtum. This goes fairly quickly. Yeah, here it says it's unpacking Qtum 0.20.1 over 0.19.1. This is updating to the latest version of Qtum. If you want to run the update manually at a later time, because there's a new version, use this command here. Update and install. And it's done. So the next step would be to launch the qtumd superstaker. So this assumes that Qtum is installed, which we just did from the AMI, and that we're signed in to our instance and ready to start issuing commands. So we'll issue the command to start up the qtumd superstaker with these parameters. We're on testnet, so we'll give it that parameter. We want the daemon wallet, which runs in the background for super staking. Our staking minimum fee is 10%, and the minimum size UTXO that we'll stake is 100. And we use this reindex command, which creates some additional databases that the superstaker needs. Now, because we're running in the background, we can use the Linux tail command to see the output going to the debug.log file. And you can see the staker is happily synchronizing the blockchain. It's getting all the headers first, and after it has all the headers, then it'll start downloading the blocks. So we will jump ahead in this process to save some time in the video here. Use Control-C, hold down on the Control button and press C to exit out of that tail command. So we'll wait a little bit and then go check it again. If it doesn't make a connection to appear right away, you can use this add node command, but this is looking pretty good. When the blockchain is syncing, it will give you the progress as it goes along. So when it's first starting to download the blocks here, it will say progress equals 0.00 something. It's going pretty fast here. Let me stop that. So yeah, here it says 0.01. So that's like 1% of the blocks downloaded by this point. And if we skip forward in time a little bit, actually we'll just check on the basic wallet while it's downloading the blocks. You can say get info command. You can see we're version 0.20.01. That's good. Blocks 27,000 of 741,000 needed, so it's just getting started. The verification progress is another way to check the sync status is 0.03, 3%. It has one connection and no coins in it. So while it's downloading the blockchain, we can do some other housekeeping. We will get the address, get an address in the wallet that we'll use for our super staker. We'll use the get address command for that. And there's our address, lowercase q, because we're on testnet. MUV. We're going to copy and paste this command into our text file because we'll need the address later for some other commands. So we're going to fill it in two places. And we'll come back to that in a little bit. Of course, use your own address for your own installation. And we'll just save that. Where are we here? So we want to let the wallet fully sync. That would be progress equals 1.000. We can check and see how it's doing. You can use the up arrow to get previous commands. So here we are about 5 minutes later, and it's halfway synced because progress says 0.49, which is 49%. And then if we jump forward in time, and 16 minutes later, progress equals 1.000. So we're fully synced at this point. And that whole thing took a little less than half an hour on AWS, which is pretty fast. Now we're going to encrypt the wallet because we're going to send some coins to it, even though they're testnet coins. We'll use the encrypt wallet command. Going back to the terminal, press Control-C to exit out of the tail. So there's our command. We're going to encrypt the wallet and then always use a long and strong passphrase. Of course, use your own passphrase in here. And there it says you need to make a new backup because your wallet.dat file is encrypted. Your wallet is encrypted at this point. And we'll do that in a little bit. Actually, we'll do it now. So we installed WinSCP before. Now we're going to run it and copy that wallet, the wallet.dat file, to our local Windows computer. So here we launch WinSCP and make sure that new site is selected. That's what you'll see the first time running it. And we want this to be SFTP, secure FTP. Now we need to know the name of our instance. So for that we're going to go back to the AWS console. And instance is running. Instance ID. And here it is. Public IPv4 DNS. We'll copy that and save it into our text file. This tells WinSCP where to find our instance. And again, the username is Ubuntu, so we'll fill that in. And for our password, we're going to use that private key file. So click on the Advanced button here. And we want to go down to SSH authentication. And we'll need to tweak the .pem file a little bit. Windows SCP wants to use a different type of private key file, a .ppk, which is the format for PuTTY, which WinSCP is part of that family. So we'll say to open that file and it will very helpfully convert it to the PuTTY format for us. And we'll save it. Here it's telling us that it's converting it. Okay. And then we'll save that connection, which it will show us in the left window here. There we go. Now we can log in using the login button. So at this point on the right hand side you've got the VPS instance. On the left hand side you've got your local Windows computer. We want to show the hidden files though. So we'll go to Settings, Panels, and up at the top, Show Hidden Files. And there they are, lots of hidden files. We want to go to the Qtum data directory, which is in .qtum here. We're looking for the wallet.dat file. We'll go to testnet3 because we're using testnet. We'll go to the wallets directory, and there it is, wallet.dat. So now's the easy part. After we did all that setup, we're just going to drag that wallet.dat file over to the left-hand side to our desktop AWS folder. You see it's got the two private key files in there. That's good. And we're going to drag the wallet.dat file, which will back it up on our local computer. This is important because if you stopped your instance on AWS, it would throw away all your memory, including that wallet.dat file. So you really want to back it up on your local computer. And of course, best practice would be to actually try it out and make sure you got a good copy. Now we're back on the instance, having backed up the wallet.dat file. We sent this wallet 1001 test Qtum. We can take a look at it here. There is one UTXO with 1001 size, which is fine for sending, but for staking, we want to split that up into 100 Qtum-sized UTXOs. To do that, we'll use the split command, which is essentially a transaction that we're going to send back to the wallet. To do that, we need to fully unlock the wallet with the wallet passphrase command. We'll unlock it for 600 seconds here, which is 5 minutes, which is enough time to do the split command. These 100 sized UTXOs will be used for committing stakes by the super staker. Now we pasted the address of our super staker into this command before, so we're all set. And we're going to split this address, there's our super staker, into 100 minimum, 200 maximum size. This by default will do 100 outputs up to 10,000 Qtum. If your wallet is bigger than that, run the command multiple times or set it for more outputs. Now when we run the list unspent command, we should see 10 UTXOs because it split them all up. But of course, we have to wait for the next block to publish to complete that transaction. So we jump ahead 3 minutes. Now with the command, we can see there's our last one, which is a little bit bigger than 100. And we've got 9 other UTXOs that are exactly 100 size. So that's good. At this point, we're basically done setting up the super staker. We can give it the last command for that, which is to unlock it for staking only, which is our wallet passphrase command again. But this time, instead of 600 seconds, we're going to say 999 seconds, which is about 2 years. And this true parameter means unlock for staking only. Now I also sent this super staker a delegation, so we can check the delegation using the get delegations for staker command. So let's go ahead and paste that in there. Again, you need to know the address of the super staker. And we should see all the delegations. In this case, there's one. There's the delegate address, and the fee I set was 10%. That's the required fee by the super staker, and it shows the block height that the assignment was made, and the weight is 0 because they're immature coins, and we'll see how that works in a little bit. We can monitor the staker to see what's going on. After 500 confirmations, the coins will be mature and it will start staking. But we can see what's happening now with the get wallet information command, get wallet info. So I see the balance of 1000.998, paid a little fee for that split command, that's why it's no longer 1001. And what else can we see here? Oh, it's unlocked until, this was that really long time, which is, actually it's about 4 years from now. We'll be updating the wallet or resetting it or something before then, so we should be okay. We can also look at the get staking info command. This is a very important command for running a staker. Staking is false, weight is 0, delegate weight is 0. Here we're going to wait 18 hours. And then we'll log into the wallet and check again with the staking command. And we should see mature coins now. Notice now it says staking is true because we have mature coins, so it can be staking. And you can see the weight for the staker is 1,000. It gives it in satoshis here, so you just convert by moving the decimal point over 8 places. Right there. So it's 1,000.998, and the delegate weight is 2909. And the expected time in seconds gives you about 51 hours to a block reward. A few more things, just running the wallet. Good idea to know how to stop it and start it up again. To stop the wallet from running, use the stop command. The instance is still running here, we're just stopping the Qtum wallet. And then to restart it, we'll use that same command that we used before, except we don't have to say reindex because it's already made those additional address and log info databases. So otherwise it's the same command we used before. You can also stop and start the instance if you want to do that. That's safe to do now because we've backed up the wallet.dat file. So we can start it up again. We'd have to copy the wallet.dat file back to AWS to restore that same address in the wallet. To exit our PowerShell session, we'll type exit. I'm sorry, that exits out of AWS. Now we'll do a security cleanup. We've got this AWS file on desktop with our password files, our private key files, and our wallet.dat file. But of course, you want to back that up to one or more USB thumb drives to keep it safe. Plug in a thumb drive here, and we'll just copy this over. And let me show you some other things you might encounter depending on your setup. So there we go, we'll put that USB drive in a safe place. If you are using a child account, not the main account on Windows, if you go to log in there with your private key files, you get this rather impressive warning, because Amazon is very helpfully saying that your private key file isn't as safe as it could be because it's in your family account, your secondary account, and the main account could also access that private key file, which makes it unsafe. So you can clean that up. Last, we can look at some block rewards that have come in. It's 7 days later when we log into the AWS session and do get info. We can see, first I wanted to show you, I mentioned before, incoming connections. We've got 36 because we opened that port 13888 for incoming connections. Then we have a stake of 100.4, which shows that we have a current stake committed by this wallet. Get staking info gives you similar information. We always want to see staking as true here. It also shows, this information about the staking operations. It's really easier to monitor the wallet to see the stakes though by looking at the Explorer, and we've got 2 block rewards to consider here. First is a block reward of 4.0 that the staker got for its own UTXOs. So it gets the full amount, 100 quantum in for the stake, 104 out, giving it the 4.0 for the block reward. That's for its own inventory of UTXOs. For the delegated address, it receives a payment of 0.4, so 100 go in, and it gets back 100.4. The 0.4 is 10% of the block reward, which is the staker's fee, and the delegate gets 3.6 quantum for the block reward, which is 90% of the block reward. And that's how block rewards work. Finish up here with some references. All the commands you can get out of the text blog file, you can copy and paste those. That's qtum-tech.info/qtumd-aws, and some other references here. The text blog gives the reference for the swap file if you want to do that. Please subscribe, and to see the previous version of the blog, click here.